forget to like and subscribe this channel.
Now let's continue the second part of lecture 3. For the learning outcome in this video, students should be able to differentiate between amorphous and crystalline solids, then state the following types of crystalline solids with appropriate examples. Number 1, metallic. Number 2, ionic. Number 3, molecular covalent. And number 4, giant covalent. Now let's look at types of solid. There are two types of solid, which are crystalline solid and amorphous solid. So there are few differences between these type of solids. The first one is in terms of the arrangement. For crystalline solid, the atoms, ions or molecules are ordered in well-defined arrangement, or in other words, lattice structure is extended in all directions. While for amorphous solid, the atoms, ions or molecules have no orderly structure, or the arrangement of the atoms are random. Next, let's look at the formation of this solid. For crystalline solid, it is formed when a saturated liquid is cooled slowly, while amorphous solid is formed when the saturated liquid is cooled rapidly. The next one, when crystalline solid is cut, they split perfectly into even size. But for amorphous solid, when they are cut, they break into uneven pieces. The next one, for crystalline solid, its atom, molecules or ions occupy specific position. But amorphous solid, its atoms, molecules or ions occupy random position. Examples of crystalline solid are snowflake, sugar, and table salt, while examples for amorphous solid, glass, plastic material, and charcoal. So the conclusion here, both amorphous and crystalline solid may look alike in terms of appearance, but they are different from each other in terms of their physical properties. Now let's look at types of crystalline solid. There are four types of crystalline solid. The first one is metallic solid, ionic solid, molecular covalent solid, and giant covalent solid. Now let's look at metallic solid. So metallic solid is closely packed structure and composed of positively metal ions immersed in the sea of delocalized electrons attracted to each other by metallic bond. So all metallic elements are metallic solid. For example, elements from group 1, group 2, and also transition metals. This is an example of sea of delocalized electron for sodium. Positively sodium ions, which is immersed in the sea of electron of sodium. Now let's look at ionic solid. Ionic solid consists of ions, cation and anion, which are held together by ionic bonds. An example of ionic solid is sodium chloride, which is also known as table salt in the kitchen. In ACl, there is lattice structure of Na plus and Cl minus, which is attached to one another by strong ionic bonds. So all salt which consists of ionic bond is also known as ionic solid. Now let's look at molecular covalent solid. Molecular covalent solid is composed of molecules held together by intermolecular forces which is van der Waals forces or hydrogen bonds. Let's look at the example. Please change the example given in your notes to glucose, ice, and sulfur because the examples given in your lecture notes is incorrect. Oxygen is in the form of gas, so it is not solid. Water is liquid, and ammonia is gas, so we cannot consider them as solid. Please change all these examples. So now let's look at this molecule here. This is H2O. So when H2O convert into solid, it is also known as ice. So between each H2O molecules, there is strong hydrogen bond. So all solid molecules which are held together by van der Waals forces or hydrogen bonds, therefore they are known as molecular covalent solid. Now let's look at giant covalent solid. Giant covalent solid is very large molecule. It is composed of atoms which are linked together by strong covalent bond. Examples of giant covalent solid are diamond, graphite, and silicon oxide. Each carbon atom in diamond is tetrahedrally bonded to one another by strong covalent bond. The same goes to graphite and also silicon dioxide. But for graphite, between each layer of carbon, there is weak van der Waals forces. This is the structure of diamond. Each carbon atom is bonded to another carbon atom by strong covalent bond. While the structure of graphite, there is strong covalent bond between each carbon atom, but between each layer there is weak van der Waals forces that hold the layers together. This diagram shows the ionic bond in NaCl, while the diagram below here shows the sea of delocalized electron in metals. This diagram here shows formation of strong covalent bond between each carbon atom, while the diagram below here shows the formation of hydrogen bond between each H2O molecules. Now let's look at the comparison between gas, liquid, and solid. The first one is the shape and volume. For gas and liquid, since the particles can move past one another, therefore the shape and volume will follow the shape of container. But solid retains a fixed volume and shape since they have rigid particles that lock into place. In terms of compressibility, gas is highly compressible, while liquid is harder to compress, and solid is very hard to compress since there is very little space between the particles. The last one, in terms of flow, gas and liquid can flow easily since the particles can move past one another, but solid does not flow because the particles do not move past one another.